I realized I told you guys I would have this posted this afternoon, but trust me, you wanted me to remake this video. I had stayed up all night and made the first one, and it was around 6:30 by the time I finished the first one, and I was really tired by the time I got through the second one, and things were not making sense. So I decided just to start over today, and so I'm going to finish up the part 2 of 3.4. In this lesson, we're looking at the concept of a shadow price. So we want to sometimes look at the economic impact of the changes on the constraints, not just of the profit contribution that either of the product types that we're looking at. So what if maybe we had more labor hours available or more supplies, or the machines could run longer, or we had more machines, something like that. So we're looking at a concept called the shadow, and that's a D, price. We're going to define the shadow price for the ith resource. So this is associated with the ith constraint. So like we have a first constraint for maybe there's a total for number of minutes for machine 1, or the second constraint is the number of minutes for machine 2. So that's what we mean by the ith constraint. We define the shadow price for the ith resource to be the amount by which the value of the objective function is improved. So in other words, either increased in a maximization problem or decreased, which we don't really see any of those problems in this particular section, in a minimization problem. If the right-hand side, semicolon, the constraint is changed by 1 unit. So the textbook will take you through the generic H value added to any constraint, and then they specify the shadow price for H equal to 1. So that's what we're going to fill in down here. So when we consider shadow price, we're only interested in the case of H equals 1. And I'm actually not going to do any examples of the generic H case. If you're interested in that, you can read through the text. All right, so let's jump into that same example we were in the first video. We're going back to the 2 types of souvenirs. And this is actually going to use the same system as before. It's got the same information. You'll notice we've got the profit of type A, $1 each, the type B, $1.20 each. We've still got that the type A requires the 2 minutes on machine 1, the 1 minute machine 2. Type B, still the 1 minute machine 1, 3 minutes machine 2. We've still only got 3 hours available on machine 1 and only 5 hours available on machine 2. So we're interested in finding the shadow price for resource 1. And sometimes they'll say resource 1, sometimes they'll say requirement 1, or sometimes they'll just say constraint 1. So to recall that system, we had, we were maximizing P equals, and of course we had $1 for every A, and then $1.20 for every Y. And we were maximizing. And then our first constraint was the 2x plus y, which was less than or equal to 180. And x plus 3y, which was less than or equal to 300. And the non-negative constraints, x and y greater than or equal to 0. So when we do the shadow pricing, what I mean by that for resource 1, so this is constraint number 1, this is constraint number 2. So resource 1, constraint 1, we're just increasing it by literally 1. And we're going to see what happens to the system. So this is a new system, but it's fairly changed. The graph is very, very similar. It's just a small difference there. So we can still solve this system. We know that it's going to have the same basic shape. It's going to have that same maximization corner point idea. It's just going to move just a little bit. So let's do an RREF to figure that corner point out. And we can do a 2, 1, and now it's going to be 181. And then we're going to have a 1, 3, and 300. So that's the corner point we were looking at in the graph. You can look back if you need to at your notes to see what that looked like. So grab your calculator, and we can type this on in. I think I've already got it in mine. So second matrix, edit, 2 by 3. So 2, 1, 181, 1, 3, 300. All right. So we're going to go to second quit, and we're going to matrix, and we're going to go over to math, and just do a quick little REF of A. And this is going to give us a row reduced matrix. Now, it's important to note here these decimals are exact. Anytime you get decimals that continue on, you need to do math enter, and that's going to happen sometimes on WebAssign. All right. So before, remember, our solution was the ordered pair 48 and 84. So there's a slight difference here in where that intersection point is, but it's very, very, very close. All right. So we end up with 48.6 and 83.8 exact. And if you want to change those fractions, you can. But these are exact, so we can plug them on in. So let's see what happens to profit here. So our new profit now, so this is for the new system, we'd have 48.6 for X, and then plus 1.2 times that 83.8. And let's plug that on in here. All right, so we have 149.16. And I believe when we did the old one, let me recalculate. I don't have it sitting in front of me. I'll just take a second to do that. Oh, well, maybe not. I think it was 148.80. Is that correct? Yes, that was correct. All right. So the old P was 148.80. So the way we compute the shadow price is just looking at the difference in those. We're going to take our new P minus our old P. So our new P is 149.16 minus our old P is 148.8. And if this had been cost, we would use new C and old C. And so subtracting those out, we end up with 36 cents. And since that shadow price is positive, that means the changing of the constraint had a positive effect on profit. That means it's a binding constraint. So anytime down here at the bottom, and I'm going to have to move my paper up. That's one thing I forgot to do in the video that I made early this morning. So I'll let you get that written down. Okay, so moving up down here, anytime a shadow price for constraint is positive, and you have to start with the new minus the old, that means it is a binding constraint. So this means that the objective function cannot be increased without increasing these resources. And typically, most of the constraints are going to be binding if they're in the form of something like this one. If it's something like a x and a y greater than or equal to 0, or even like a x greater than or equal to 25, or y greater than or equal to 4, something like one of those vertical or horizontal lines, then you're going to have a non-binding constraint, because typically those don't have an effect of increasing the objective function or decreasing of its cost. All right, so you're going to have group work. The first 2 problems in class for the group work on WebAssign are going to be instructor guided, and then there's 3 problems you're going to do with the group on your own. And those are going to be, I think the first one is just a generic kind of maximize or minimize, I can't remember which one. And then the other 2 are word problems. All right, so we'll see you in class. Thanks.